Hi all, my name is Catherine, Assistant Professor from the Department of AML, SNS College of Technology, Coimbatore. Today in our lecture series, we shall see about the Elgamal public key encryption algorithm. So earlier in the case study, I told you what is an RSA algorithm and how it works. Here, this Elgamal algorithm provides an alternate to this RSA for public key encryption. So the security of the RSA depends on the presumed difficulty of factoring large integers. So I told you have to take two large prime numbers in RSA algorithm. So security of the Elgamal algorithm depends upon the difficulty of computing discrete logs in a large prime modulus. So Elgamal has the disadvantage that the ciphertext is twice as long as the plain text. It has the advantage the same plain text gives a different ciphertext each time it is encrypted. So that is the advantage of this Elgamal public key crypto system. So here in this algorithm, Alice chooses a large prime number P, say 200 to 300 digits. So a primitive element alpha, A modulo PA, A possibly random integer, and DA with which lies between 2 to -2. And Alice computes beta A, which is congruent to alpha A, and DA mod PA. Alice public key is now PA, alpha A, beta A. Her private key is DA. So now in public key crypto systems, as you know, you have to generate two keys, public key as well as the private key. So here the Alice public key would be the PA and the alpha A and the beta A, whereas she keeps her private key as DA. So what Bob does is Bob encrypts a short message M such that M is less than PA and sends it to Alice like this. Bob chooses a random integer K which he keeps as secret. So now Bob computes R is equal to alpha A alpha A into K mod PA, and T is equal to beta A K M mod PA, and then discards the K. So Bob sends his encrypted message R, T to Alice. When Alice receives the encrypted message, she decrypts using her private key DA by computing TR power minus DA. So note that TR minus DA is equal to beta A KM. So basically, it is in decryption part, you will do the inverse of whatever you are doing in the encryption. So even if anybody intercepts the ciphertext R, T, she cannot perform the calculation above because she does not know DA. So this encryption and the decryption part relies upon the private key of Alice, DA. So anybody who has access to anything else, they cannot do the encryption part and the decryption part. So beta A is computed such that alpha A into DA mod PA. So DA is equal to L into alpha A BA. Eve can find DA if she can compute a discrete log at the large prime modulus P, presumably a computation that is too difficult to be practical. They can do it, but the time that takes for to compute this is not worth. They have to really compare whether computing this is worth the time and the energy they are spending on it. So if M is a longer message, so it is divided into blocks. He should choose a different K for each block. Say he encrypts two messages or blocks M1 and M2 using the same K, producing R1, T2 is equal to alpha A into K, beta A into K M1, R2, T2 is equal to alpha A into K, beta A into K into M2. So the message is considered to be longer. She or she has to divide it into blocks depending upon them. So this is how this Elgamal public key crypto system works. They have the computation part is here. Difficulty of computing discrete logs in a large prime number is difficult in this Elgamal public key crypto systems, whereas the security of the RSA relies on the factoring the large integers, the two large prime numbers. So that is how is all about this Elgamal public key crypto system. I hope you all understood. Thank you.